Okay, so here I have a 99 to 01 firewall harness. You can see our C115 connector here. Trace it all the way back. It'll go into these three firewall plugs and your main fuse box. Here I also have the auxiliary relay box. This one's the one that is found underneath the air cleaner. It doesn't have our mounting tabs like the 96-97 box does, but it has these little tabs right here where you could actually fab a little bracket that kind of slides in there, just a piece of strap steel. Mount that to your fender, and then this guy would slide in and sit on it just fine. If you're going to use this style of relay box, you need to get the big main fuse box out of the Explorer, because we need those proprietary pins that we talked about in the other video. If you have a 96-97, right about where I made my cut here, you would have your auxiliary relay box there. At that point, just make the cut forward of the relay box just before the headlights, so that you know that you have all the wiring that you're going to need. Now, where we're actually going to start here is with the main fuse box. You can see these tabs here for the lower cover. We're going to pull this lower cover off, and then here inside the relay box you can see these banks held the relays. Our PCM diode went there, and then from here on is just fuses. Well, you might consider disassembling this in the junkyard. The only reason for that, I know my local junkyard hits me for an extra 30 bucks if I have one of these boxes attached. So what I'll do is, you can see these little black tabs in the corners here. I'll actually disassemble this thing in the junkyard, just pull those black tabs, and you can drop each one of these banks out the bottom. And then on the fuse box side, I just cut the wires to the fuses, because you aren't going to need any of those. The only thing you're really going to need are the relay ones and the two connectors for your PCM diode. Now here you can see I've dropped the 4 banks out, and I've cut everything that went to the fuses, since we don't need those terminals. We're only concerned about reusing the relays. Here's kind of what our butchered fuse box looks like now. This will go in the trash. So the next thing we're going to do, these top plastic pieces here, they're just like your retainers on any other connector. We're going to pop these out, and then every one of these pins we're going to remove. We won't use all of them, don't worry. Now inside there you can see the little retaining tab. There's 2 on each one on each side. That'll let you pull these off, and then you can get inside there and depin every one of these. You aren't going to use them all. Just pull them out so that you have them ready. Makes it easier to pick your donor one that you're going to use. Okay, so now I've got all of my blocks pulled out, and this is the mess I'm left with. Saved all of our pins for the relays, cut off every one that went to the fuses, and now we're going to do the same thing to our relay box. We'll ditch our relays. This red retainer under here, there's 2 of them, 1 on each side. We do it just like we did these guys here. Has tabs underneath. We'll pull that out the bottom, and then we'll pull all the pins out of this, and we'll be ready for a clean slate for adding our own wires to it. Now with our red retaining blocks out, to pull the pins just like we did on the other one, I figure I'll give you a little tip here. The jeweler's screwdriver works really well for the relay block stuff. Not so much with this guy. He's better for like your round style pins like you have in your PCM connector, your C115. So I find this guy easier for the relays. Alright, so I've got all my pins removed from my auxiliary relay box. The next step here, we're going to come back to our C115 connector. You're going to match up the pins with this with the pins that are on your engine harness. Anything that you have removed from your engine harness, you're going to remove from here. Then with what we're left with are going to be wires that are either going to come here and have the pins for the relays, or they're going to come to these three firewall connectors. So with what you're left with, you're going to trace it out, pull them from here, pull them from here. Now on the firewall side, for what we're doing, we're just going to go ahead and cut whichever wire we need off. You can get real creative and depin this. These guys come off by just doing a quarter turn in either direction, and then the cover will come off. You can pull out these retainers, depin it like anything else. If you want to get fancy, you can just repin all those once we're said and done into one of these connectors to use to pass through the firewall. I'm not going to cover how to do that here, just telling you it's an option. So if you do have an entire Explorer donor, you'll need the wiring under the dash, but it is kind of a neat way to do it. What I'm going to be doing is just cutting them from here. We're just going to pass through the firewall using a grommet. Now, when you're removing these from here and tracing back, there's a few I should point out. This solid red wire here, this is PCM power. It will be coming from the PCM relay. When you trace it back, it's going to come into the harness here, and you'll find that it comes to a big splice that has a bunch of them coming out. Go ahead and just cut it from the splice for now. We'll take one of the pins later and re-splice it back in so that it's just one wire. This yellow wire right next to it, this is used for keep alive memory. You're going to follow it in, it's going to come into a splice in here somewhere too. Just cut it from the splice. This green with a yellow stripe on it, this is the fuel pump. This is the monitor circuit here. When you trace it, it's going to come up into here, and you're going to have a relay terminal on it. Sometimes you'll have two wires coming out, sometimes it's just one. If it is just one, you're going to find a splice where it branches into two. Now on this fuel pump wire, we're going to want both ends of it, so we want this one here, and we'll trace it to where it comes into the firewall plugs, and we'll just cut it from the firewall plug. Another one to point out here, this other one in the corner, it's red with a green stripe. That's power to the coils. When you trace it up through here, it's going to come into one of these connectors. Here it is here. With the this was the connector for the PCM diode. You really only need one side, but I would just go ahead and remove it from both for now, and you'll cut off the one that you don't need later. Now in this other corner here, you can see this big yellow wire here. Now a 96, 97 harness isn't going to have this. 96, 97 harness will have another ground wire like this one here. They really went overkill with the ground and the 96, 97 stuff. This yellow one here is our yellow wire at our alternator plug. So if you're doing like I did, and just kind of adding a fuse at the alternator to keep it simple, you can remove this guy. If not, trace him back wherever he ends up here and cut him out of his splice, and you can run him to his own dedicated fuse in your fuse box if you're running one with enough slots. This corner ground wire right here, He's going to go into a big splice somewhere. Just cut him at the splice. Remember, if you're 96, 97, you're going to have another one that's probably going to go into the same splice with him. You'll remove both of those from there. Okay, so now I've got my C115 connector removed from the rest of the firewall wiring. I'm left with this big mess coming off of it here. I'm going to go ahead and walk you guys through what every one of these wires does, what their function is. I haven't removed any of them, so we're even going to cover some of the stuff that you probably aren't going to use. The C115 connector, there are diagrams for it online. If you choose to use any of those diagrams, really take it with a grain of salt. I've seen a lot of discrepancies in them, and also there were quite a few changes over the years. I'm going to be doing this one with a 99 harness. I figured this is the best one to show you because 99 to 01 are completely identical. I believe 98 is the same on the C115 as well, but don't hold me to that. 96 and 97 are going to have some differences, and I am going to try and explain what most of those are to you as we go along. Now, as we go along, another thing that we're going to want to do is separate the wires into two different sides. Right now I have it with pin number 1 up here at the top left. Numbers are upside down, but holding it in this orientation, I'm going to try and describe which ones you want to bring off to this left side, which ones you want to bring off to the right, and cover some of their functions. So starting off with this pin number 1 here, this is red with a green stripe. This is power to your ignition coils. So we're going to connect this to our ignition relay, and all the stuff going out to the relay box we're going to have off to the right hand side. Number 2 here looks like brown with a yellow stripe. That is tax signal. Since you don't have a distributor anymore, the computer has to generate a tax signal, and this seems to work with all your aftermarket tax as well as OE as well. This one's going to come inside the car, so we'll bring this one off to the left hand side. Now moving on to number 3, you can see it is twisted up in a pair of wires here. Now what that pair of wires is for runs to your OBD2 port, and the reason they're twisted is to prevent interference because you're sending data between your scan tool that's plugged into the OBD2 port and the computer on those lines. Since we'll be mounting our OBD2 port inside, both of these wires, the one right underneath it as well, it'll come off to the left. Now this next one, pin number 4, this is also red with a green stripe, kind of like our coil wire, but it's a thinner gauge wire, and on your 96, 97 stuff I want to say that this wire is green. It's not going to be red with a green stripe. What this goes to is the brake light switch. We want to wire it so that it's hot anytime you're on the brakes. The computer uses it for things like torque converter lockup and also to know if you're in decel mode. You also need it for doing any sort of a key-on engine running test. At a certain point in the test, the scan tool will tell you you need to step on the brake. If you don't provide that brake input, then it won't continue running the test. So it's pretty important to have. This green with the yellow stripe, this is our fuel pump monitor circuit. If we trace it out, you'll see it comes into a splice here, and this is the terminal for our fuel pump relay. So both wires are usually pretty heavy gauge on the 96, 97 stuff. you'll find that the monitor wire where it comes back to the C115 is a smaller gauge on some of the later stuff. The other end of this wire is going to end up running inside the cab, and you'll connect that to your inertia switch, and then the other side of the inertia switch will feed your fuel pump. And in some cases you won't have that splice in the middle. What you'll actually have is two wires coming out of the relay terminal. So we want this end going to the relay box, so we're going to make that wire come off to the right hand side. Next up, this is pink with a green stripe. What this wire is for your check engine light. So we're going to bring it off to the left hand side. Now the way the check engine light works is the computer actually grounds the bulb. The other side of the bulb, you need to wire it so that it's hot anytime the key is on. That's kind of important. You don't want it hot all the time, otherwise you can have weird power backfeeding issues. So this will ground your check engine light bulb, and make sure the other side's hot only with the key when the key is on. This gray with a black stripe here, this is the vehicle speed sensor plus wire. This wire actually comes from the ABS controller, and coming through here will be the input into the computer. Most of you guys are probably going to delete this, but if you want to run a VSS and you want to use like maybe a Dakota digital speedometer, or feeling spunky and want to try on cruise control, you're going to need this guy. I would tap into I would add a VSS plug to the engine harness, but use this as an output so that you can run it to either speedometer or cruise control if you're going to use it. If you're going to go cruise control with it, I would bring it off to the right hand side. If you were going to go inside the cab, I would come off to the left hand side. This next wire up on our list is a solid yellow wire. His function is keep alive memory to the computer. So this wire needs to be hot all the time. It's not going to draw really any current, so I mean you could get away with 2, 3, 4 amp fuse if you wanted. I believe that it's always fused with the 10 from the factory. The only other circuit that needs to be powered all the time like this wire is going to be pin 16 of our OBD2 port. Now there's a couple places we could get power from. If we have an extra slot in our fuse box, we can bring this off to the right hand side along with a splice somewhere to feed the OBD2 port power, and we can just give it a spot in our fuse box. Another option, some of the harnesses like Painless, they'll actually provide like a memory wire for the radio, or you might have some other harness that has extra slots. If you want to go that route, bring it off to the left so it's in the cab, and wire it, label it, hook it up to a spare fuse or to a radio memory circuit, but it needs to be hot all the time. This last wire in this row is a solid red wire. This is a fairly heavy gauge wire. This wire is going to connect to our PCM relay. This wire is actually what powers up the computer when the key is on. It also kind of branches off, provides power to the injectors, the IAC, and a few other sensors. If you're 96, 97, like the cam sensor, I believe it'll feed as well. MAF sensor. But this is the main power to the computer. We're going to get the power from a relay, so break this one off to the right hand side. Now moving on to our second row here, this one's pin 10. It's a yellow with a white stripe. I would say 99% of you guys are going to remove this wire. It's not going to be used. Its function was that it got a signal from the instrument cluster for fuel level in the tank. You can't hook it to a fuel level sender because the resistance is way out there. The instrument cluster got the signal from fuel level sender, then converted it to a different signal that it sends the computer on this line. Now, the only reason the computer would want to know fuel level is for evap functions. So if you want to try and add the overly complicated Explorer evap system to whatever vehicle you're going to put this in, then you will need this wire. Of course, assuming you aren't running an Explorer instrument cluster along with fuel level sender, what you can do is, I believe, about an 80,000 ohm resistor between this wire and ground will make your tank read 50% at all times. The reason that's sort of important is because from some of the research I've done, the evap functions and tests don't run when the tank is anywhere, or they will only run if the tank is between 15 and 85%. So if you're empty or full, it's not going to work. So you would have to trick it, make it think it's somewhere in between that 15 and 85% for it to work. Now this next wire here is part of that twisted pair that we went over with, going to the OBD2 port. So we're going to skip onto this guy here. He is tan with a white stripe. His function is for the overdrive switch. This lets you lock overdrive from coming on. The way he gets wired inside the cab is to a momentary switch. That means it's only providing power when you push the switch. The other side of the switch will be wired to hot and run only. And it just takes a quick blip of power on this line, and then the computer will cycle between allowing overdrive to kick on or locking you out of overdrive. Now this next wire here is purple with a white stripe. Again, this is one that most of you guys probably aren't going to use because it is for the Explorer evap system. This wire ran to the canister vent solenoid and would ground it for it to operate. The other wire on the canister vent solenoid would be hot and run if you're interested in trying to adapt that Explorer evap system over. What I actually like to do with this wire is at the PCM, I will remove it from the PCM. It will be pin 67, it looks like, on the PCM, and I actually move it to pin number 41. The reason I do that is because 41 on the PCM on these later harnesses is a purple wire, and it doesn't have a stripe, just a purple wire. And there's another wire that we'll get to in a little bit here that is also purple. Pin 67 is located almost right above pin 41 in the PCM, so I kind of cheat and I'll move 67 to 41, and that makes 41 purple with the white instead of just solid purple. It helps me to keep track of it. I know that's probably confusing to you, but that's the way I do it. Now, if you're going to use it for the evap functions, I would probably bring it off to the right hand side. That way you can bring a solenoid out next to your relay box or something of that nature. If you're moving this pin to 41 just to try and keep track of it like I do, its function is it needs to be hot when the AC clutch is operating. So from your AC clutch relay, you would energize this. that would then tell the PCM to bump the idle up a little bit so that there wasn't such a bog on the motor as soon as that AC compressor clutch kicked on. We'll cover AC a little more as we go along, but that's the gist of it. If you aren't going to run AC, with a little trickery inside the computer, I can reprogram it to where it will bump the idle speed up to, say, 1200 RPM or so anytime you shoot power on that wire. The purpose of that would be for like onboard air or winching or something of that nature, so you can take advantage of a higher idle speed. It's pretty handy, actually. The last wire in this row is light blue with an orange stripe. Now you'll find that there's actually two other wires in this mess here that are relatively the same color. This one happens to be ground control for the fuel pump. The fuel pump grounds, or the PCM grounds the fuel pump relay to command the pump on. So this guy will run off to the right hand side because he'll be in the relay box to control that relay. Alright, moving on to our next row of wires. We have a red with a white stripe. Notice this is in pin 16. It's not in 33. If for any reason you have a red with a white stripe in pin 33, it should have been removed already, just to avoid confusion with this one. This one is just our coolant temp sender wire for our gauge. We'll run it inside, so it'll go off to the left hand side here, and it'll go to the back of our temp gauge. This isn't required. This is only if you're keeping your gauge wiring inside your Explorer harness and not using your existing wiring. This next wire here is pink with a red stripe. This is another one of those that 90% of you aren't going to use. What this one goes to is the fuel tank pressure sensor. It's used during the evap purge process. So 90% of you are going to get rid of it. Moving on to the one next to it, we have gray with a red stripe. Now, if you remember from all of our O2 sensor wiring and covering some of the other sensors, this wire here is our signal return. The only reason you would have him coming out of this connector on this side would be for this fuel tank pressure sender. So 99% of you guys are going to remove that one. Same goes for this next one on our list. This is brown with a white stripe. Now this one here is our 5-volt reference. Again, the only thing that this is going to be used for on this side of the harness is the fuel tank pressure sender. So it's one of those wires that 99% of you guys are going to remove. The last one in this row is black with a pink stripe. You're only going to use this one with 4R70W. Remember on our 4R70W that our transmission range sensor is also our reverse light switch and our neutral safety switch. Well, this black with a pink would be power coming out of the reverse light switch and feeding the reverse lights. So you would probably go under the dash with him to tap into your factory wiring. So I would bring him off to the left hand side. Now moving on to our next row, we have one of our two purple wires here. This one's sitting in pin number 22. What this wire is going to go to is our OBD2 port. Now technically you could probably get rid of this wire if you wanted to. I always keep it in. The reason being is this wire here is used for reflashing the computer. Your scan tool or tuning device, whatever you're going to use, actually has to send 19 volts on this wire to enter programming mode. Now, if you're the kind of guy that's going to be wrenching on your own stuff, it's not going to hurt you to leave it in. But if you're the kind of guy that would take it somewhere that would reflash your computer just to be a nice guy to you, to get you the newest update, that will ruin your tune. So, you know, if there's any possibility of that happening, I would remove it. But kind of optional. I always keep it in. This next wire here is a solid pink. You know, again, because the transmission range sensor provides our neutral safety switch features. This is the start signal from the ignition switch. So you would bring this off to the left side because it's going in the cab, and it would get wired to your ignition switch to where it's only hot and start because it's just our crank signal. And over here we have purple with an orange stripe. Again, it's going to be 4R70W use only, kind of like our pink or our black with pink. What this wire is the power in to the reverse light switch for your reverse lights. You know, power out comes out here, but power in comes through here. You're going to want to fuse this at like 10 amps. That should be plenty for your backup lamps. And the way I set it up, I usually bring this off to the left-hand side, tap into the existing wiring under the dash to provide power to it. You could run it to the right side and go to our fuse box if you wanted, if you have enough slots, but just kind of a matter of preference there. And again, it's one of those things you're only going to use if you're doing the 4R70W, and that's assuming you didn't break those wires out at the transmission range sensor. Next up is our green with a white stripe. This is our oil pressure sender for our gauge. So if you're keeping the gauge wiring in your harness, bring this one over to the left-hand side, and it'll get wired up to your gauge under the dash. Now in our next row, the first wire we come to is this pink with the yellow stripe. This is one of those ones that I pretty much remove out of all of them, but I'll tell you its purpose and let you make up your own mind about it. In the later harnesses, later computers, this wire here actually controls the AC compressor relay. The computer's in control of it. For simplicity reasons, I remove him. The only feature that you're really going to lose by removing it is the computer will not cut the AC out when you're in wide open throttle mode. You know, if that feature is important to you, then you could keep it in place, email me for the diagrams, and you could kind of duplicate what they did from the factory. All I really like to do is just have one wire to signal the computer to kick the idle up. Don't really want the computer in control of the AC. And also, I don't know how compatible the computer is going to be with other systems' AC pressure switches. So, yeah, I typically recommend removing him. This last wire in this row, you can see is tan with a red stripe. Now, in your later harnesses, he's going to be red with a blue stripe. Again, 4R70W use only. And this is the neutral safety switch out. So this wire will technically go to your S terminal on your starter solenoid to crank the motor over when you're in park or neutral. Now moving on to our last row here, you can see we have a fairly heavy gauge black with a white stripe. This is ground for the computer, kind of self-explanatory there. there's only one in the 98 to 01 harnesses. If you're working with a 96, 97, this yellow with a white wire that's on the opposite corner will also be a ground. Like I said, they kind of went overkill with the grounds on those, considering the system was fed with a single 14 gauge red wire. But if you have an earlier harness, you'll ground this one, and it'll be a black and white on this corner. You'll ground them at the same spot. This next wire is black with the yellow. You're only going to find him on 98 and later harnesses. He went to one of the AC pressure switches originally. This wire gets grounded to allow AC operation. So what I usually do in the name of simplicity is I will run this wire to ground along with our other one here. That way it's grounded all the time, and then that way to trigger AC or high idle we only have to shoot power to the one wire, just keeping it simple. This next wire here, blue with an orange stripe, you'll notice it's a heavier gauge wire than our one that was over here that controlled our fuel pump relay, but it is the same color. And it's also going to your relay box as well, so might be worth labeling now. But this wire is for the O2 sensor heater circuits. We will power him up from the O2 sensor relay. And on later harnesses like this one, this will actually also provide power to our transmission shift solenoids as well. Now this next purple wire, this is the one that I usually do away with because I use the purple and white over here like we kind of discussed earlier. But this is the wire for the AC system that needs to be hot anytime that compressor clutch is running. So if you aren't moving the pin 67 to 41 on the computer, you can use this guy here. Just don't confuse him with our other purple one, and you'll provide power to him anytime your AC compressor clutch is running, or if you're taking advantage of the high idle switch that I like to program in. Now, one more thing I should point out on this purple wire that would be hot to command high idle for AC. If you're working with a 96 or 97 harness, this wire won't be purple, and it will be a dark green with an orange stripe. This next wire is green with a black stripe. This goes to your vapor valve, which is pretty much just a purge valve for the Explorer systems. It's a smidge more complicated on them. So it's one of those wires that 99.9% of you guys are going to remove. However, if you're feeling really spunky, I can program the Explorer computers to where it uses a single purge valve, kind of like your Mustang EFI system would do. And in that case, you could use this guy to ground that purge solenoid. The other side of your solenoid will be hot and run only. And that way it would simplify everything, and you could have evap operation. The catch to that is I have never tested it in a vehicle yet to confirm that it works. It does work on the bench when I command the purge solenoid to function, but I can't say, if the computer will actually command it while it's going down the road, despite me programming it that way. A lot of criteria probably has to be met, one of which might be our yellow with a white stripe having the right resistance value for purge operation to work. Like I said, I never confirmed that it works, but if you really want evap, I would give it a shot. Our next wire here is white with a green stripe. And what he is our overdrive off light. The computer grounds this line anytime the overdrive is locked out because you manually requested it. You'll wire it up just like a check engine light. This wire will ground the bulb. The other side of your bulb needs to be hot and run only. And since he's going to be going into the cab, he will go off to this left side. This next wire that we have is a light green with a red stripe. That wire is to energize the alternator if you're working with a later harness. It's only going to be present in 98 to 01. He can actually be used for a dual purpose depending on how you're handling your alternator wiring. You can wire him to a bulb just like you would this guy or the check engine light, to where the other side of that bulb is hot and run, and it will actually act as a charge light as well to let you know that the alternator is not charging. Just kind of depends on if you're going to keep the alternator wiring in the harness or not. Another thing I should point out to you is, if you're using an LED for your other bulbs, that's fine. But because this guy actually energizes the alternator, you can't use an LED on him. It has to be just your regular old conventional bulb. Otherwise the alternator won't charge. If you're keeping the alternator wiring in your harness, you have no use for that charge light indicator. I believe you can just wire this to where it's hot when the key is on, and that way the alternator gets energized. And our last wire here is a fairly heavy gauge yellow with a white stripe. He's only going to be present on the 98 and later harnesses, because on a 96, 97 he's going to be another ground just like this one here. But this is the alternator sense wire. If you're setting it up the simple way like I do, where I just run him back over to the charge post with a fuse, you aren't going to use him. But if you're going to use a bigger fuse box, you can give him his own dedicated fuse. I would run him off to the right hand side and then fuse him there. And he will be fused all the time. It won't be a switched power, it'll be constant. That circuit doesn't get any use unless it's energized by this guy here. So that covers all of the functions. Pretty much every wire that I think that you're going to encounter. I think I've covered all the differences with the 96, 97 stuff, but if any questions pop up, you guys can always email me. I throw my email address up at the end. And now I'm going to get to removing what I don't need and break mine down into the left versus right, and we'll continue on. Okay, so now I have my C115 connector split into two different directions. Everything going to the relay box on this side, everything that goes into the cab on this side. Now, there's going to be a couple wires that we're going to add to run between. And the first one we're going to start with is we need to get power to the OBD2 port. Now, you can just add a wire in there on the inside of the cab and wire it up to like radio fuse, or you can do it like I'm going to do here. What I'm going to do is I'm going to cut our keep alive memory wire here, and I'll take the wire from it and I'll bring it back over into this side of the cab, and I'll make a splice with those two together, and I'll feed it with a yellow 16 gauge wire to get it out to our fuse and relay box. And that's how I'm going to power them up. Just need to know that whichever way you do it, you need power on this yellow wire at all times. You want it fused for the size of the wire, and you need power to pin 16 of the OBD2 port, again fused for whatever size wire you're going to use. I put the two together just for simplicity. Now here you can see the splice that I've made. This portion here is coming in from the fusing relay box. One of these comes down and feeds the computer for keep alive memory, and the other one's running into our cab, and that'll provide power to our OBD2 port. Now next I'm going to add our 14 gauge green. It'll come from this wire on the fuel pump circuit, the one that's not going to the C115 to monitor the PCM. It'll run the entire length and into the cab. And you need to make sure that it's long enough once it's in the cab to get to either kick panel so that you can mount your inertia switch. So we'll get that 14 gauge green wire installed in here. And then the next one we're going to add is going to be a red one. And that needs to make it all the way from the fuse and relay box over here. Make it the same length as your wires over here where they end. And the purpose of that one is going to be, it's going to provide power from your ignition switch to your relays to turn the whole system on. Okay, so now we have our 3 wires added. Our yellow to power our OBD2 port, our green for our fuel pump, and our red from our ignition switch to power our relays. Now on the red, where it comes out on this side by the relays, I just labeled it run so that I know that that's my ignition switch run circuit, and I don't confuse it for the other red that's slightly bigger in diameter. That is our PCM power. Now the next thing that we're going to do is add our OBD2 port to the harness. You actually might want to wait to do this until you have it installed in the cab. That way you can get the length perfect of where you want to mount this. I don't have that luxury, and I'm going to go ahead and show you how to do it now. I took the 4 OBD2 port wires and just kind of kept them together with tape for now. You have our twisted pair, so that's kind of obvious. We have our yellow wire here, that is the wire we added for power. And then we have our purple wire here that's kind of optional and only used for flashing. Now remember, if you're working with a later harness, there are 2 purple wires that you might have. If you didn't catch all my confusion with changing the other one to purple with the white, you can make sure that this is the one that you need. It's pin 13 on the OBD2 port. It's also pin 13 on the PCM connector. So you can plug your engine harness in and ohm pin 13 to this one, and you should have continuity to make sure you're working with the right one. Now there are some modifications that we're going to make to this OBD2 port. We've got 2 ground wires that are pins 4 and 5. One's black with a white stripe and one's just black. On this one here, you can see it comes up to a splice up here. We're just going to cut it right here at the splice. We're going to add a ring terminal, and then that way we can just ground both of these wires to chassis ground once it's installed in the car. You see this blue with a white stripe on pin 7 here. This wire we aren't going to use at all. It's for communicating with other modules like ABS, airbag, anti-theft, and that kind of stuff. So we will depin it from the OBD2 port. Now, depinning OBD2 is a little different than the rest of them. This is your retainer tab, and it will actually come out this backside. You can see these little tabs that hold it in. Just get yourself a flat-bladed screwdriver and get underneath it and pull it out the backside. From there, it's just like anything else. You'll put your pick in, grab the little tab, pry it away, and then you can pull that wire out the back. Now, pin 16, which is the very last pin in our OBD2 port, if you're looking at it this way, that's pin 16. The color will change quite a bit depending on what you pull your OBD2 port out of. You can pull it out of any 96 to 04 Ford, but I've seen this wire be all kinds of different colors. This is the power wire to power up your scan tool, and we're going to connect this one to our yellow power feed that we added. Now, when we're matching up our colors with our twisted pair and our purple, what we want to do is we want to solder the twisted pair together first. That way, once we're done soldering it, we can twist it all back up so that you still have the RF resistance, and then we'll solder our purple one and our yellow. And when we solder these, we still want to do our best to stagger, kind of like we did with our O2 sensor, just so we don't have a big bundle of splices all in one spot. Alright, so here you can see I've finished the OBD2 port. We've got our 2 ground wires to an eyelet that will just ground to the chassis. I've staggered each one of my splices, that way it's not bundled up when I put loom over this section. And every one of these is just a matter of matching colors, with the exception of pin 16, which is our power for the OBD2 port. Like I said, that can be just about any color depending on what you pull your inertia or your OBD2 port out of. I like to pull them out of the Expeditions. It seems like I can get a little longer length out of those, which makes staggering my splices a little easier. So the next thing that we're going to move on to is our inertia switch. All we're really going to do here is solder the green with the yellow stripe to our green wire that we added to the harness that comes from our fuel pump relay. Pretty straightforward there. And then this pink with the black stripe, you'll just label to fuel pump, and that will power your fuel pump. Now you'll notice this little third wire here. You won't find it in every one of these, but they are there. You can remove it by pulling this tab out. Same kind of thing. Use your straight pick and release the pin, pull them out. Now what this guy does is, if the inertia switch trips, instead of sending power to the black and pink, it will send it onto here. You'll notice he's a smaller gauge wire. What it would run to would be a warning light to let you know that that inertia switch is tripped. So if you're feeling kind of spunky and it's a feature you'd like to add, you certainly can. But I'm just going to remove it myself. Now, something else I want to point out, because I do see this from time to time, it's not real common, but this is about the 3rd or 4th one I've seen out of countless numbers. You can see our wires are darkened in color here, and you can see this connector started to melt. I won't use this connector because it has started to melt and the wires are now nice and brittle. But I suspect this happens just because the tabs inside the connector there spread out a little bit. So you might consider just pulling each one of them out and slightly bending the tabs just so that they make a really good contact with your inertia switch. That way this doesn't happen. Alright, so that's about all we're going to do to this side of the harness. The rest of these wires all get hooked up inside the cab. Haven't wrapped it yet, but I just kind of made it all one big loop so it's easier to manage. Put some tape on it for now. We'll wrap that later. Now we'll move on to the tricky side. This is probably the most difficult part, but it's really not that hard. Probably the first thing that you should do is figure out what sort of distance you need from your C115 to your relay block. I find that about 34 to 36 inches works really well if you're mounting the PCM upside down to where your C115 sits slightly to the passenger side. So at 36-inch mark, I came here to each one of these wires, and at 36 inches I just put a mark across them. That way I know when I'm setting this up, my mark needs to be on the edge of this relay block. And also consider when you're putting your pins into this relay block which way your mounting tabs face. You know, if you're 96, you're going to have the ears on the side. This later one will probably make metal brackets that slide into these to hold it in place. And since we're going passenger side, the wires will come in through here. If we were going driver side, then we would probably bring it in like this. And also now would be a pretty good time to detangle all these wires, and then like every 6 inches or so just put a little wrap of electrical tape around it so they all stay kind of nice and tidy. Depending on the year of your harness, you might find that you have some splices in the middle here, especially like on our red with green. In this case, our red with green comes out here. And that's how you get the second wire. But if you have any splices in here, just run down the side of it with your razor blade really quick, heat it with your heat gun, and pull the factory heat shrink off. Get it down to where it's only one wire, and then just slide some heat shrink back over and take care of it. Okay, so now we're somewhat detangled. Got a little more tape in place to keep everything in order. Got our marks across our wires so we know where our fuse box starts. Now the first thing we need to do is there's 4 wires that need to go to our relay block that the relay block provides power to. One of them is going to be our fuel pump. And since this is a later harness, this one's going to take a micro relay. If you had a earlier harness, you might have one that looks sort of similar to this. Other one is this. This is our power to our ignition coils, so we'll make it go to a relay that says ignition. Something to note here, this is actually the wrong style tab to go in our relay block, but that doesn't mean we can't modify it. To make it fit, what we have to do, we'll bend this tab back down, and you can see this little corner right here, we'll bend him back up, and then he'll fit perfectly into one of these Bosch style relay blocks. The other one is our big fat 14 gauge red wire. We actually cut him off because of the big splice that happened over by the fuse box, but we'll take a connector from that big mess that we have left over, we'll splice it on, and we'll give him the right terminal to go into the relay block. Now note, it's not going to be this one. We labeled this one run so that we knew that it was from our ignition switch. This is the one that we want to feed to the relay for now. The last one of the 4 that you have to be kind of careful of, you'll notice these 2 here have 2 different style connectors. This one here is a relay style connector. This one actually grounds our fuel pump. It's not one that we want to send power to, and it's real easy to confuse these 2 wires because they're almost identical in color. This one will almost always be a little smaller gauge. This one here, if you depinned it from the fuse box, this has a fuse style tab on it, and it was probably located right next to our PCM relay. This is the one that we want to send power to. Obviously it doesn't have the right style terminal, so we'll go back to stealing one from our pile that we removed from the main fuse box. This is where using those snap together relay blocks is kind of handy that I was telling you about earlier, because we just cut every terminal off at whatever length we want, crimp the right one on, and we're done. Unfortunately, since this is the proprietary stuff, we just have to use what we have. So now the terminals that those 4 wires need to go to in your relay block, it's going to a standard Bosch style relay like this. It'll be this guy here, and if you look closely at the relay, it should say pin 87 on it. Can't really get into focus here. But on a Bosch it's this guy here. On a micro, we'll do it on this big pin here that's kind of in the center. So if you're looking at your relay block from the top side, it'll be this one or it will be this one, just depending on which one. I'm going to go ahead and do all 4 of them and then just kind of show you a little better. So the first one I did here was my fuel pump. I figured out my length needed for the 36 inches, and that actually let me cut out this factory splice. So I'm a fan of doing that when you can. You know, we do solder our connectors, but obviously the fewer splices the better. So I cut that factory splice out and have my relay terminal on this side, and that's my monitor wire, and that's my wire to my fuel pump. Now you aren't going to do that if you have an early one or one that has 2 wires coming out at the connector. In that case you would probably just shorten them both to your length if you want it shorter than factory, and splice them both at that point. Now the next one I did was our solid red, our PCM power, with the line for the fuel pump in place. Kind of stretch out, figure out where you need to make your splice. On this harness, this portion was kind of short, so it's up here. But at the same time, you would still want to do your best to try and stagger all of your splices. Now next up, I'm going to do our red with a green stripe. Remember, that's power to our ignition coils, and I only need 1 of these. I don't need 2 here, so I'm going to cut one off. Doesn't really matter which one, since we're trimming the length of this harness, and we'll just splice it in at the proper length. Okay, now here on my ignition coil wire, I bent this tab over, I pulled this one out, that'll let it lock into our relay block, and then I cut off my extra wire, and this is kind of where the toenail clippers come in handy, because you can trim that real close. Just be careful not to nick this wire here when you do it. Now the last feed wire that we have is for our O2 sensor circuit, and on the later harnesses this also feeds the transmission shift solenoids. Now this wire is plenty long, but I need to swap the end to have the right connector for our relays. So I'm going to use the shortest one I have that is still the same gauge wire, and that's going to be this guy here. The reason I'm going to use the shortest one is because it appears I only have 2 others that are the proper gauge, and they're nice and long, but I'm going to use them to go from the relays to the fuse panel. We'll cover that later, but do this last one up and we'll move on. Okay, so now I have my 4 circuits that get power from the relays. They're all fed. Kind of let you see what pins we're in on all of these. Now the next thing that we're going to move on to is the ground trigger for the relays. Now the PCM grounds the fuel pump, so we will install it probably right here in this top slot. if we were working with a full-size Bosch relay for the fuel pump, we could put it in either of these. Looking at the relay, it can go in either 85 or 86, it doesn't matter. It's not polarity dependent here, just as long as you have ground on one and power on the other when the key is on. It'll do what you need it to. Looking at a micro relay, it's going to be these two outside ones here. It can go to either this one or this one. And this middle one doesn't get used at all. And same thing, it's not polarity dependent. As long as we have power on one, ground on the other, it'll work. Okay, so now we have power fed to all of our circuits, and we have our ground trigger for our fuel pump installed. Now we need a ground trigger for these other three relays that we're using. Now, had this fuel pump been a full-size Bosch relay instead of a micro, it would get real simple here, because usually you will find these in just about every harness. This is the full-size Bosch connector, and these two are the micro relays with a nice long pigtail coming off of it. That would work perfect if this was a Bosch, because, well, then we'd only need to ground the PCM and 2 micros for O2 and ignition. It's not going to work out that way this time, but I'll show you a tip here. Okay, so what I've done here is I've cut this guy to where it has 2 of the connectors that we need, but this third one it doesn't have. So where I cut it off, I've stripped it, I've laid it over this terminal here, and I've used just a single strand of copper wire that I took from one of the leftovers and wrapped it really tight. Now what I'll do is I'll add a dab of flux to it, and I'll go ahead and solder it, and that'll give us a good connection, and then the leftover strands here we'll just trim with the toenail clippers. And there's the finished product. Probably not the cleanest solution in the world, but it's the best I can really think of, since we can't find these connectors in virgin form. Now I'll just trim it up and we'll install it. Alright, now we have a ground trigger in our other 3 relays. It's going right there, and right there, with this big long lead coming off of it that we need to get to ground. So, just so happens we have 2 other wires that we need to go to ground as well. One's our black with white, and the other is our black with yellow. Now this one just goes to ground for our shortcut to AC operation. Needs that ground signal at all times, and then we cycle it with power on the other line. Earlier harnesses will not have this black with yellow, but they will have a second black with white. So, and they'll usually be a heavier gauge wire than this. So on an early one you'll have 2 black with whites that you need to mate up with this guy here, and then you need a feed coming out of the harness to put your ground eyelet on. So if you're working with a 96, 97, you can usually find a big chunk of this black with green near the fuse box. You can usually get a couple feet of it. And at that point I would do these 2 on one side of your butt connector and your 2 black with whites on the other. With this harness, my black with white is plenty long, so I'm going to cut it. We're going to do the black with white and the black with yellow on one side, our feed from our relay box, and then the other end of our black with white coming out to go to a ground eyelet on it. So I'll get that done and show you what it looks like. Okay, so here's that splice finished. Got my black with yellow, my black with white. Remember, on a 96, 97, that's going to be 2 black with whites. Then I have my ground that comes over and feeds all of our relays. And then what was left of the black and white was still nice and long, so I used it. This will end up coming out of the harness, and we will put an eyelet on it so that we can ground it to the chassis. So now the next thing we need to do is we need to get ignition power to all 4 relays. So remember, on our trigger side, it's going to be the opposite of our ground trigger. So we're going to do this terminal, this one, and that one. Now, unfortunately, there isn't any real shortcuts for this like there was with the ground wire. So we're just going to go through our bin and find what we can scavenge from the leftovers to make all that work. This is one part where the uncovered relay box kind of shines, because you can just daisy chain with your own crimp connectors and make perfect little U-shapes, daisy chaining the whole thing. Now with the 4 of them together, they need to fit into one of these spades so that we can have our diode in there. If we were doing an uncovered fuse box, we would just link them all together, and we would probably keep the diode under the dash and mount it in between the ignition switch and our run wire. But yeah, I'll go ahead and put 4 together to get to all 4 relays, and then I'll show you more on how the diode works. Alright, so here's what I came up with for our power trigger. I have 4 connectors in total, 2 of the full-size Bosch type, 2 of the micro type, and then I have a decent length of lead coming off of here. So I'll go ahead and install it and show you what to do with the diode. So I've got it installed. You can see it's starting to get a little busy under here. Just make sure you can see which terminals we're going to. Now our lead coming off, we'll kind of fold it over here. We'll lay our PCM diode where this unused relay sits. That way it's not so crowded. And we're just going to clip this wire, put it on one of our crimp connectors, and if you look at the diode, you can see how there's like a little arrow there pointing the way that it goes. It's the direction that it lets the current flow. So this side here will be our run wire from our ignition switch, and it points to the relays because that's what we're energizing. So this wire here will go here, and our little wire that we labeled run, we'll trim him to length, and it'll go on the other terminal. Alright, so here's the diode installed, just hiding them under here. And this is our wire labeled run. This is the one that goes onto our ignition switch. Power feeds through the diode and comes and hits every one of these relays to trigger them. So now it's really looking busy under here, but fortunately we're just about done. We need to get power to feed every one of these relays, and we're going to do that on this pin, this one, and this one. So if you're looking at the relay itself, it would be pin 30 on a standard Bosch Tyco relay, or it would be pin 3 on a micro. So this is where you need to use fairly heavy gauge wiring, at least as heavy as the wires coming off to the circuits are feeding, like for our fuel pump and our PCM. You can go heavier, that doesn't hurt, but you don't want to go smaller. I guess I should have mentioned before, on your trigger side of the relays, you don't really need a very heavy gauge wire at all. You're probably looking at maybe an amp to feed all 4 of these relays, so save your big heavy stuff for the power feed. Now, I still have this yellow wire left over. If you remember, this one feeds our OBD2 port and our keep alive memory for the computer. Now, I don't have an extra spot in the fuse box for this one, since I only have a 4-panel fuse box. So, we could have ran it inside, came off the radio fuse, that'd be fine. But what I'm going to do is, just like this diode here, I'm going to hide a little fuse under here. And I'm going to branch it off the PCM relay. And the reason I'm going to do that is so that if you pull the PCM relay, it's still going to kill the keep alive memory as desired. But the odds of this hidden fuse blowing are pretty slim, and in fact, if it does, it's because you're having a really bad day. If this were an earlier harness where it had like 16 gauge wire feeding both of those already, then I probably wouldn't worry about the fuse. I would go ahead and tap in on the PCM fuse. The circuit's not going to draw anything, but in this scenario, this later harness, that's probably like an 18 or 20 gauge wire. It's tiny. So, fuse it 5-10 amps would be sufficient. Now, to do that, to branch it off of the PCM fuse, the earlier your harnesses will usually have something like this, and that's really good to do that with. In this case, this harness didn't have it, so I found this over in our pile of terminals. And this is probably a little overkill. I think this is 12 gauge, but we'll put this to the power side of the PCM relay. We'll snip this off and put one of our female spades on it so that we can run a fuse in there. And then this side here will just come down to our fuse box. The other 3 relays, you're just going to find a terminal that fits, that's sufficient gauge, and plug it in, and we'll run it down to the fuse box. Alright, so here I've added my fuse that feeds my OBD2 port and my keep alive memory for my computer. Now, one other option that you could do here, if you fed the OBD2 port from somewhere inside, like the radio fuse mentioned earlier, instead of doing a fuse here, you could do a diode to feed keep alive memory to the computer. I wouldn't feed the OBD2 port at the same time, because these diodes are usually only good for somewhere between 1 and 3 amps. Depending on your scan tool, you might blow it. So, but yeah, if you did a diode here instead of a fuse on only keep alive memory, that might provide you some additional protection should your wife ever get a hold of the jumper cables. Ford did not put a diode on that circuit from the factory, so I assume there may be one inside the computer. Again, this is just kind of an optional thought, and I don't really want to go hooking computers up backwards to test that theory either, so just a thought, something you could do if you wanted. So now we have power fed to our PCM relay. We need to feed power to our ignition relay, our O2 sensor / transmission solenoids on later harnesses, and to our fuel pump. Now this harness, I don't know why, but pickings were kind of slim for the terminals I wanted. Hence I'd really love to find these things in virgin form. So on my ignition side, all I could find that was the right terminal and the right gauge of wire was just this little short guy here. So I put a splice in them. Don't really like all the extra added splices, but that's kind of your only real option to run this covered fuse box. I used the wire I added to it was the leftovers that we had cut off of the terminal inside here earlier, that guy there. So he's still going to be kind of the factory color at the fuse box, so you at least know what's going on. Now our fuel pump, since this is a micro, there's really only one heavy gauge micro terminal that I see in any of the harnesses for the fuel pump. And that's this guy here. Well, once again, added another splice, but I had some wire left over from when I shortened the fuel pump lead, so I'll use that, and that helps me know which circuit that's for down at the fuse box. For our O2/transmission solenoids, we usually use this guy here. He's really, really long. It actually goes back to the wiper motor in factory form. So we'll install these three and get them run down to the fuse box. We've changed a few colors in here, a few more splices than I like. You wouldn't have to do that if you're just using the snap together stuff. But fortunately, from the fuse box on back, we're still staying true to factory colors. So, the mixed and matching, fortunately it all happens right here at the fuse box or within a couple inches of it. So, it is what it is, and I'll get these installed and show you the finished product. Alright, and there you have it. It's all put together. Got our fuse box on. We brought our ground wire out here too. We'll end up putting an eyelet on him and grounding him wherever we like. I usually prefer wherever the battery and body ground meet. We'll feed power to our solenoid here. I actually use a 6 gauge wire on mine. I think it was an old alternator cable that just had a lug on it that fit. I'm sure 6 gauge is probably overkill, but I would go just as beefy as you can. Probably 10 or bigger for sure. Now it's just a matter of wrapping the harness, but you might want to test it before you wrap, and I'll give you some tips on wrapping it too.